Hello everybody. Once again I am here with you for the another session related with the last point, that is resolving power of grating. And in this session let's see how this resolving power of grating is to be calculated. The first thing is that resolving power means to resolve the images from each other. That is the important factor using this grating, and that's what the resolving power of grating, that separating the two images. The role of the grating regarding that, how this resolving power of grating is nothing but to be defined in this calculation form, or in a relation with that the wavelength of that is lambda of any spectral line uh, to the difference in between the wavelength of the lines nearby the spectral lines. And such type of the two lines appears to be uh, just resolved condition. So here is the such type of the 2 points P1 and P2 that should be in the just resolved condition. And no doubt Mn is the screen, Xy is the whatever be the your spectral uh, surface, grating surface, and the field of view is Mn. P1 is the nth primary maxima of the spectral line of the wavelength lambda, and the P2 is the wavelength primary maxima of the spectral line of the wavelength, that is lambda plus d lambda, that is nearer next to that spectral previous line, that is lambda plus d lambda. And at a diffracting angle, that is theta n plus d theta is there. And P1 P2 are the spectral lines in the nth order, that is the maybe first order, or according to that you can take either nth order, either first, second, third, or the fourth. That type of is to be as an n theta n is written, excuse me. These two spectral lines are separated to be just resolved. Now the direction of the nth primary maxima of the wavelength lambda is in general given with the relation we know, that is the a plus b. In the simple way, small a plus b sine theta n is equal to n lambda for this bright maxima for the p1 in that case. And for the wavelength lambda plus d lambda, it is the same relation will be like this, that is small a plus b sine of theta n plus d theta is equal to n into lambda plus d lambda is there for the next line, or the nearer spectral line is there, those two spectral lines nearer to each other. And as according to the Rayleigh's criteria, we know that just resolved condition is that where the maxima, when the two spectral lines are very close to each other, in that case the central bright maxima, the angle of diffraction also corresponding to the direction of the first secondary minima after the nth primary maxima at P1, that is the फर्स्ट पहिल्याचा जो मॅक्सिमा असेल, जर समजा हा फर्स्ट जर कन्सिडर केला, तर सेकंड नियरर जो स्पेक्ट्रम आहे त्याचा फर्स्ट मिनिमा याच्याशी तो ओव्हरलॅप झाला पाहिजे, किंवा व्हाईस वर्सा. दिस इज व्हॉट द जस्ट रिझॉल्व्ड कंडिशन. अँड टू गेट द जस्ट रिझॉल्व्ड कंडिशन, in this case the whatever be the nearer spectral line that is having the relation a plus b sin theta n plus d theta is equal to n into lambda plus d lambda, हे जे इक्वेशन आहे याच्यामध्ये जर समजा मी लॅम्बडा बाय n एवढ्या n नंबर ऑफ टोटल लाईन्स ऑन द ग्रॅटिंग सरफेस, दॅट इज कॅपिटल n इज देअर, एवढ्यानी जर लॅम्बडा बाय n एवढ्यानी जर समजा इन्क्रीज झाली तर जस्ट रिझॉल्व्ड कंडिशन सॅटिस्फाय होते. And that's why this second equation I can write in this fashion as an a plus b sine of theta n plus d theta is equal to n lambda plus lambda by n is there. So that is what the previous, what the condition is to be, to get satisfied with that we need to be correct, increase the value by lambda by n. So from the equation 2 and 3, if you look at this case, the left hand sides are equal, then according to that I can write the right hand sides are going to be equal. So the relationship, or the relationship we have, n into lambda plus d lambda is equal to n lambda plus lambda by n. याच्यामध्ये जर समजा याला मल्टिप्लाय केलं तर n लॅम्बडा प्लस n d लॅम्बडा इज इक्वल टू n लॅम्बडा प्लस लॅम्बडा बाय n. मग हे n लॅम्बडा जो आहे हा इथं पॉझिटिव्ह आहे, राईट साईडला गेला तर मायनस n लॅम्बडा होईल आणि हा n लॅम्बडा आणि हा n लॅम्बडा कॅन्सल होऊन जाईल. सो द रिमेनिंग व्हॅल्यू विल बी हियर इट इज टू बी n d लॅम्बडा इज इक्वल टू लॅम्बडा बाय n. मग ह्याच्यात जर समजा हा d लॅम्बडा इकडे घेतला आणि हा n जर इकडे घेतला तर वी हॅव रिलेशन लॅम्बडा बाय d लॅम्बडा इज इक्वल टू small n into capital N is there. So this is what the relationship, that is the this quantity is measures the resolving power of grating is there, because the spectral line divided by difference in the spectral line d lambda, the resolving power of grating is independent of the grating constant, and the resolving power is directly proportional to the order of the spectrum and the total number of lines on the grating surface. And this is what the relationship is showing. For a given grating, the distance between the spectral line is double in the second order spectrum than that in the first order spectrum, and the dispersive power of grating is given by, this is what the dispersive power, that is d theta by d lambda is equal to n upon a plus b cos of theta, which is n into n dash upon cos of theta. So this is what the relationship is to be there, and n is the number of lines per centimeter on the grating surface. Theta gives the direction of the nth principal maxima corresponding to the wavelength lambda, and the dispersive power increases with the increase in the number of lines per centimeter. Also the resolving power increases with the increase in the total number of lines on the grating surface. जेवढा प्रमाणात number of lines जास्त असतील तेवढा प्रमाणात dispersive power ही increase होत जाईल. No doubt, according to that spectrum is going to be there. High dispersive power refers to the wide separation of the spectral lines, whereas high resolving power refers the ability of the instruments to show nearby spectral lines as separate ones. So, as spectral lines as separate ones are there. So this is what the conditions are there for to get the resolving power, that is lambda by d lambda is there. And thank you for joining this session. Be at home and be safe. Thank you.